In this video, we're going to cover the examples of graphing secant and cosecant. Recall that when graphing secant and cosecant, the goal is to specifically graph sine and cosine and then convert it to its reciprocal function and therefore basically flip all those fractions. Remember, flipping those fractions in terms of the points that we already have in the graph. Sines, zeros will go to asymptotes, and if there are any asymptotes, they will go to zeros. So if we start by trying to graph a cosecant function, specifically one that correlates with a sine function, we are going to go ahead and see that y equals, let's go ahead and do 3 cosecant of, let's do pi over 3x. So in this particular function, what we're going to do is we're going to start by identifying a, not the amplitude, but the value of the anchor points in terms of their heights. We're going to go ahead and find the period as well as the phase shift. Now the phase shift, there isn't one because there's no c value here. Our amplitude is going to be a positive 3. Again, technically not an amplitude. Sine and cosine are the only two trig functions that actually have an amplitude. And then my period value here is going to be 2 pi. Now remember that cosecant correlates to specifically that of sine. So we're going to use all the same formulas for sine. So my amplitude, technically a, will be the absolute value of a. My period value will be 2 pi divided by b. And my phase shift will be negative c over b. So in this case, I'm going to have 2 pi divided by pi over 3, in which case that's going to go ahead and keep flip change that with the fractions and give me a value of 6. So when I go to graph cosecant, again, the goal here is to, I'm going to go ahead and sketch a small version of this, where my last point is 6, cut that in half is 3 halves, multiply that by 3 is 9 halves, and then don't forget 0 is also included in there. Cosecant is supposed to correlate with sine, so I'm going to go ahead and plot those points logically here, 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 and here. But we have to remember that every location where there was a 0, that will now be an asymptote. So in my actual function for cosecant, what I'm going to have here is the same exact anchor points. 6, cut that in half is 3, cut that in half is 3 halves, multiply that by 3 is 9 halves. And don't forget 0. Those 0 locations now turn into asymptotes. The high point stays at the high point of 3. The low point stays at the low point of negative 3. And then it graphs again away from the axes. More appropriately, if this were to go like this, again, we're graphing away from where those lines are curving. So because this is supposed to come down like this in the original sine function, the cosecant function is going to go outwards like this. So that's your graph of 3 cosecant of pi over 3x. And again, notice that if we do have a pi value in our b, we will end up having no pi's or radian measure values in the axes. So if we're looking at secant, let's go ahead and look at a secant that actually has a phase shift in it to review how that process should be done. So we're going to go ahead and use y equals, let's do a negative 1/2 of secant of 3x plus, let's do pi over 4. So this is going to be a relatively heavy one to deal with. It might take some extra steps and some extra details before we get to the final result. Let's go ahead and go through it. My amplitude or my anchor point values is going to be 1/2. I'm going to make note that it's flipped vertically. My b value, my period, is going to be 2 pi divided by 3. And that's not going to be able to simplify in any way because it's just divided by this. And then finally my phase shift. My phase shift, recall, is a negative c divided by b. And again, if I keep flip change this, it's going to be this fraction divided by 3, which is then multiplied by 1/3. So it's going to be equal to a negative pi divided by 12. What I'm going to do next is, because every time that I deal with the phase shift, I think it's a little bit more easier to handle, is by identifying what my delta x is. Again, remember the delta x is nothing more than your period value divided by 4. So if I take 2 pi over 3 and I divide it by 4, that's going to give me 2 pi over 12. Yes, that can be simplified to pi over 6, but I'm going to go ahead and leave it as 2 pi over 12 because remember, most of the steps that we take to graphing these functions is I'm going to find a common denominator between my phase shift and my delta x anyways. So The next detail that I'm going to do is I'm going to go ahead and draw a small sketch of the secant function. The secant function is the reciprocal of cosine, and I'm going to go ahead and do it based on this period value. So 2 pi over 3, divide that by 2 is pi over 3, divide that by 2 is pi over 6, multiply that value by 3 is 3 pi over 6 or pi over 2. Don't forget 0. This is without the phase shift. So this is me just dealing with these values here. The secant function is supposed to be the cosine function flipped, so it's supposed to have the high point. When I say flipped, again, I mean the reciprocal. So it's supposed to have its high point here, then 0, low point, 0, high point. But remember, we're going to go ahead and flip this thing vertically. So I'm going to make these points very clear right now that it's going to go low asymptote, high asymptote, low. Again, technically the way that this is going to pan out is that if I were to graph the cosine function, it would look something like this. But I'm not graphing the cosine function, I'm graphing the secant function, so everywhere I find a 0, those are going to turn into asymptotes. And then I'm going to have these, again, points here, here, and here. So what does the secant function actually look like? Well, remember, it's going to graph towards the asymptote away from the original curve. So you're going to have those 3 pieces that are going to be graphed. This one, and this one. That's my secant function. So now all I have to do is I have to take all 5 of these anchor points with the graph in tow and shift it by this phase shift negative pi over 12. So very carefully, because I'm shifting it in the negative direction, again, the plus sign and the negative sign, they have to alternate. I'm going to go ahead and give myself plenty of space here on both sides of the both sides of the y-axis. And I'm going to go ahead and be very careful about this. I'm going to start with 0, and I'm going to phase shift that value by negative pi over 12. That's the first step always, is take the phase shift, add it to that 0 value, add it to 0. So in here I'm going to go ahead and put negative pi over 12. The next thing I have to do is I have to register that the distance between 0 and pi over 6 is pi over 6. It's that, again, 2 pi over 12 value, which is really pi over 6. But 2 pi over 12 is twice the distance of this pi over 12. So you have to keep in mind that I'm going to go from here to here, that's 1 pi over 12. Here, go about the same distance. That right there is going to be my next point after I add this value. That's technically this asymptote shifted. So that there is going to be my 2 pi over 12 plus pi over 12 is pi over 12. I'm going to go ahead and take that distance and I'm going to shift it over. I'm going to copy it. I'm going to take that distance, shift it over, and I'm going to copy it. So that's 1, 2, 3, 4, and I need one more. There's my fifth dash. So there are the 5 locations that I need. 1, 2, 3, 4, 5. If I add 2 pi over 12 to each of these, this will be 3 pi over 12. This will be 5 pi over 12. And this will be 7 pi over 12. I can simplify this one here to be pi over 4, and we should do so if we can. Then I'm going to go ahead and identify each point. Remember, the secant function looks like this, such that the second and the fourth are asymptotes. So this one here is an asymptote. This one here is an asymptote. It's supposed to, again, normally be high, but it's low because it's flipped vertically. So I'm going to go ahead and be very careful about this, making sure that I identify here as a 1/2 value and then down here as a negative 1/2 value. But keep in mind, we are not plotting anything on this y-axis. It is no longer an anchor point. I've got 1, 2, 3, 4, 5. Those are my 5 anchor points. Those are the only locations where I'm going to plot a point. So I'm going to start by going ahead and plotting a point right here at the negative 1/2 value, because that's where it's supposed to be plotted, and it's going to go ahead and curve down. Again, there's nothing it necessarily passes through here. There is a point it passes through, but we don't know it and we don't really care. Next, at 3 pi over 12, we're going to go ahead and plot the high point, which is right about there, again at 1/2, and it's going to curve up, tracing that asymptote. And finally, we have, again, the negative 1 down here one more time, straight across to that negative 1/2. Let me ignore that point. And then it's going to go ahead and curve down just like the other one did. And that right there is your y equals negative 1/2 secant of 3x plus pi over 4. The focus of these problems is, again, to make sure that you understand what the graph looks like first and foremost, identify all these values, and then shift things appropriately after we've gotten the basic idea of what the graph looks like. That is the most efficient way to graph sine, cosine, secant, cosecant, tangent, and cotangent. The main focus is making sure you know what those graphs look like and take the steps to evaluate them and graph them afterwards.